What if I told you that Japan released over 200,000 ducks into rice fields across the country, creating an army of feathered agricultural workers that eliminated pesticides, increased yields by 20%, and generated 40% higher farm income? It sounds like agricultural madness, right? Well, Japan actually implemented this on a massive scale. And the result 1 year later is so insane that it's revolutionizing agriculture across 15+ countries, while proving that ancient farming wisdom can outperform modern industrial chemicals. But here's what makes this story truly mind-blowing. These ducks aren't just pest control. They're perfect agricultural partners that do 6 different farm jobs simultaneously while producing premium meat as a bonus. Picture this. You're standing at the edge of a Japanese rice paddy in early summer, and instead of seeing the usual still water reflecting the sky, you're watching thousands of ducks swimming energetically through the young rice plants. They're diving, dabbling, and paddling constantly, creating a scene that looks more like organized chaos than farming. But this isn't chaos. It's precision agriculture using nature's most efficient workers. Each duck is simultaneously performing multiple agricultural tasks, eating pest insects and snails, fertilizing the soil with their droppings, oxygenating the water with their paddling, stirring up nutrients from the mud, preventing weed growth through their constant movement, and strengthening rice plants through gentle stimulation. The ducks work tirelessly from sunrise to sunset, requiring no supervision, no fuel, no repairs, and no pesticides. They're essentially solar-powered agricultural robots that reproduce themselves, provide meat as a byproduct, and actually enjoy their work. It's the ultimate example of agricultural symbiosis, a relationship where both ducks and rice benefit from each other's presence. The scale of what Japan has achieved is staggering. Over 200,000 ducks now work in rice paddies across the country, with each duck capable of managing about 100 square meters of rice field. The total area under duck rice farming exceeds 20,000 hectares, producing rice that commands premium prices in organic food markets, while generating higher profits than conventional chemical-dependent farming. But perhaps most remarkably, the practice isn't new. It's an ancient technique called aigamo farming that was nearly forgotten during Japan's post-war agricultural modernization. What was once dismissed as primitive has become the cutting edge of sustainable agriculture, proving that sometimes the oldest solutions are the most sophisticated. The agricultural transformation extends far beyond pest control. Duck rice paddies support 300% higher biodiversity than chemically treated fields. The premium organic rice sells for 50% more than conventional rice. Farmer income increases by 40% despite using 0 pesticides or chemical fertilizers. And the duck meat generated as a byproduct provides additional revenue streams that make the system economically irresistible. The success challenges everything modern agricultural science taught about the necessity of chemical inputs for productive farming. What began as a few Japanese farmers reviving traditional methods became an agricultural revolution that's spreading globally and redefining sustainable food production. But to understand how ducks became agricultural workers in Japan, we need to go back to the pesticide crisis that threatened both human health and agricultural sustainability. Post-war Japan embraced industrial agriculture with enthusiasm, adopting chemical pesticides and synthetic fertilizers that promised to maximize yields and feed the growing population. Rice paddies were transformed from complex ecosystems into chemically dependent monocultures that required increasing inputs to maintain production. By the 1970s, the consequences of chemical-intensive farming were becoming undeniable. Pesticide residues in food raised health concerns for consumers and farmers alike. Beneficial insects and wildlife that had coexisted with rice farming for centuries were being eliminated. Water pollution from agricultural runoff contaminated rivers and coastal areas. Farmer health problems linked to pesticide exposure were reaching crisis levels. The numbers painted a disturbing picture. Japanese farmers were using over 12 kilograms of pesticides per hectare annually, among the highest rates in the world. Pesticide poisoning cases among farm workers numbered in the thousands. Bird populations in agricultural areas had declined by over 60% since industrial agriculture adoption. Most critically, the chemical approach was becoming economically unsustainable. Pesticide costs consumed increasingly large portions of farm income, while pest resistance required ever higher application rates. The treadmill of chemical dependency was bankrupting small farmers who couldn't afford escalating input costs. Environmental awareness was growing as Japanese society recognized that industrial agriculture was destroying the countryside's ecological health. Rice paddies that had once supported complex ecosystems teeming with insects, fish, birds, and aquatic plants had become sterile environments where only rice and pests could survive. Consumer demand for organic food was emerging as urban Japanese worried about pesticide residues in their daily rice consumption. But organic rice production was minimal because farmers believed pest control was impossible without chemicals. The perceived choice was between chemical-dependent conventional farming or economically unviable organic production with massive pest losses. That's when Takao Furuno, a Japanese farmer and researcher, revived and refined the ancient Aigamo method that had been practiced sporadically for centuries but dismissed as impractical for modern agriculture. His systematic documentation of the technique's benefits sparked a revolution. The Aigamo method that Furuno pioneered uses a specific duck breed, a cross between wild mallards and domestic ducks, that possesses ideal characteristics for rice paddy work. These ducks are small enough not to damage young rice plants, energetic enough to work continuously, and hardy enough to thrive in outdoor paddy conditions. The timing of duck introduction is critical. Ducklings are released into paddies 10 to 20 days after rice transplanting, when plants are established enough to withstand duck activity, but weeds haven't yet taken hold. The ducks remain in the fields for 60–80 days until just before rice flowering, when they're removed to prevent grain damage. During their time in the paddies, the ducks provide an extraordinary range of agricultural services that would otherwise require multiple chemical and mechanical interventions. Their pest control is comprehensive. They eat virtually every insect pest that threatens rice, including leafhoppers, plant hoppers, and various larvae that can devastate crops. They're particularly effective against golden apple snails, invasive mollusks that cause enormous rice losses in many Asian countries. The weed control provided by ducks is perhaps even more valuable than pest control. Their constant paddling and dabbling disturbs weed seedlings before they can establish, while their feeding eliminates weed seeds floating on the water surface. This mechanical and biological weed suppression eliminates the need for herbicides that represent major input costs in conventional farming. Fertilization from duck droppings provides perfectly balanced organic nutrients that rice plants can absorb continuously throughout the growing season. Unlike chemical fertilizers that provide nutrient pulses that can cause environmental problems, duck fertilization creates steady nutrient availability that optimizes rice growth while preventing water pollution. Water oxygenation from duck paddling prevents the anaerobic conditions that cause rice root rot and methane emissions. The constant water circulation created by duck swimming maintains oxygen levels that keep soil microbes healthy and rice plants vigorous. This natural aeration eliminates the need for expensive water management systems. Soil stirring from duck activity prevents compaction while releasing nutrients from mud sediments. The duck's constant movement maintains loose, well-aerated soil conditions that enhance root growth and nutrient uptake. This natural tillage improves soil structure without mechanical intervention. Plant strengthening occurs through gentle physical stimulation from duck movement. Rice plants touching ducks develop thicker stems and stronger root systems, a phenomenon similar to how wind strengthens trees. This mechanical conditioning creates rice plants more resistant to lodging, falling over during storms. The economic analysis of duck rice farming reveals multiple income streams that make it more profitable than conventional farming, despite slightly lower yields. Premium organic rice sells for 50 to 100% more than conventional rice. Duck meat provides additional income as the ducks are harvested after paddy work completes. Duck eggs generated during the breeding season create another revenue stream. Input cost savings are equally impressive. Zero pesticide purchases eliminate major expenses. Reduced fertilizer needs cut costs dramatically. Lower labor requirements for weeding and pest management save time and money. Reduced water pumping from natural oxygenation lowers energy costs. The initial investment is modest. Ducklings cost approximately $2 to $3 each. Electric fencing to contain ducks in paddies requires one-time installation costs of about $500 per hectare. Simple shelters for ducks cost minimal amounts. Total startup investment typically recovers within a single growing season through premium rice prices and duck meat sales. Risk management improves substantially as diversified income streams provide insurance against price fluctuations. If rice prices drop, duck meat sales maintain farm income. If duck markets weaken, rice revenues support the farm. This diversification creates stability that single-crop chemical farming cannot provide. Labor patterns shift toward more rewarding farm work. Instead of applying chemicals in protective gear, farmers spend time managing ducks. Work that's safer, more enjoyable, and creates stronger farmer connection to agricultural ecosystems. The psychological benefits of chemical-free farming enhance farmer well-being beyond economic improvements. By the 1990s, Furuno's detailed documentation and demonstration farms had convinced hundreds of Japanese farmers to attempt igamo farming. The early results exceeded expectations as farmers discovered that duck-rice symbiosis wasn't just environmentally friendly, but economically superior to chemical farming. The expansion of igamo farming across Japan from 2000 to 2024 revealed agricultural transformations that revolutionized understanding of sustainable food production and ecological farming systems. Scientific studies documented rice yield increases of 10 to 20% compared to chemically managed fields, surprising researchers who expected organic farming to produce lower yields. The explanation lay in the multiple benefits ducks provided: comprehensive pest and weed control, optimal fertilization, improved soil conditions, and strengthened plants combined to create ideal growing conditions that chemicals alone couldn't achieve. Biodiversity comparisons showed duck rice paddies supporting ecosystem complexity comparable to natural wetlands. Insect diversity was 400% higher than in chemically treated fields. Amphibian populations recovered dramatically as pesticide-free paddies provided ideal breeding habitat. Bird diversity increased 300% as insectivorous birds found abundant food in duck rice systems. Water quality measurements revealed that runoff from duck rice paddies contained zero pesticide residues and minimal nutrient pollution compared to conventional fields. The closed-loop nutrient cycling created by ducks eliminated the water contamination that made conventional rice farming a major pollution source. Soil health assessments showed organic matter increases of 30–50% after just 5 years of duck rice farming. Beneficial soil microorganism populations exploded in chemical-free conditions. Soil structure improved dramatically through natural tillage from duck activity. The soil regeneration created long-term productivity improvements impossible with chemical farming. Carbon sequestration calculations revealed that duck rice farming captured significantly more atmospheric carbon than conventional farming. The enhanced soil organic matter and reduced methane emissions created climate benefits that made duck rice farming carbon negative despite producing food. The human health benefits extended beyond eliminating pesticide exposure. Studies showed reduced disease rates in farming communities that adopted igamo methods. The safer, more physically diverse work patterns created health improvements beyond chemical elimination. Consumer acceptance exceeded expectations as Japanese shoppers embraced igamo rice despite premium prices. The compelling story of ducks working in harmony with rice resonated with consumers seeking authentic organic food with verifiable production methods. Igamo rice became synonymous with highest quality organic agriculture. Economic success stories proliferated as farmers shared their improved income and quality of life after adopting duck rice farming. Media coverage of profitable organic farming challenged narratives that claimed only industrial agriculture could feed populations affordably. International interest exploded as agricultural researchers and farmers from around the world visited Japan to study igamo techniques. The method's success demonstrated that ecological farming could outperform chemical agriculture economically, while providing superior environmental and social benefits. South Korea rapidly adopted igamo farming, with thousands of farmers implementing the technique across major rice-growing regions. The cultural and agricultural similarities to Japan facilitated technology transfer that created another major center of duck rice farming. China began experimenting with IGMO methods in regions facing pesticide pollution problems. The potential for improving both food safety and farm income in a country with hundreds of millions of rice farmers created enormous interest in duck rice techniques. Southeast Asian nations including Vietnam, Thailand, and Philippines investigated IGMO farming for addressing pesticide overuse and declining farm profitability. International development organizations promoted duck rice farming as a sustainable agriculture approach for small farmers. European organic farmers adapted IGMO principles for different crops and climates. While rice paddies are limited in Europe, the concept of using livestock for integrated pest management inspired innovations in vegetable and grain production. African rice-growing regions explored duck integration for controlling pest snails that cause massive yield losses. The technique offered pest control solutions for farmers who couldn't afford expensive pesticides. Latin American rice producers studied IGMO methods for reducing chemical dependence while improving farm economics. The success in Asia provided proof that motivated experimentation in different agricultural contexts. Agricultural education programs worldwide began teaching IGMO farming as exemplifying ecological farming principles. Universities established demonstration farms, showing how traditional wisdom combined with modern knowledge could create agricultural systems superior to industrial approaches. Research expanded into optimizing duck breeds, timing, and management for different rice varieties and climates. Scientific investigation legitimized IGMO farming while improving techniques that enhanced its accessibility for diverse farmers. Today, over 15 countries practice some form of duck rice farming, with hundreds of thousands of farmers implementing the technique across millions of hectares. The ancient method has become a modern agricultural revolution, proving that nature's workers can outperform chemicals. From pesticide crisis to ecological solution, from forgotten tradition to agricultural innovation, from Japanese revival to global movement. IGMO farming demonstrates that sustainable agriculture isn't just environmentally necessary, but economically superior. The 200,000 ducks swimming through Japanese rice paddies have become ambassadors for agriculture that works with nature rather than against it, creating food systems that benefit farmers, consumers, and ecosystems simultaneously. What other traditional agricultural practices do you think modern farming should revive to create more sustainable and profitable food systems?